Okay, so now that we have this, what we need to do is actually allow us to select the piece, have it selected, and move to a valid square. Now, that also involves having to figure out where can we move to, like what is a valid square, right? And if we move and we say jump over a piece, how do we remove that piece? How do we get rid of it? Can we jump and double jump? Like those are the things we have to figure out now, which are kind of difficult, but obviously if we're going to do them, it won't be that hard. Okay, so I'm going to make another file inside of Checkers, and I'm going to call this game.py. Now, what this is going to be responsible for is handling actually the game. So figuring out like whose turn is it? Did we select a piece? Is this piece good? Like, can we move here? Can we move there? That's what game is going to do. And it's going to use board and a bunch of other stuff to do that for us. It's also going to handle like drawing everything and a bunch of other stuff. All right, so now we're going to code out the game class. Now, the whole point of the game class is going to be to let us actually interface with the board and the pieces and everything else with a few really simple methods. So essentially, I don't want this main kind of loop that's actually running and checking for us pressing buttons and stuff to be associated at all with how this game operates. I want this game to be able to be operated by, in theory, two computers, right? I don't want it to be linked in directly to us pressing buttons and all of that, because later on, what we'll do is implement an AI so we can play against it, right? So we need to make sure that it's very clear that game just exposes some methods that we can use, but it's not dependent on the fact that we're pressing certain things or that two human players are playing. That's kind of what I'm trying to get at here with the point with this. So let's define the class. Let's import Pygame like that. Let's say divine __init self. And do we need anything else for game? We're actually going to take the window that we want to draw this game on. So we could put the window in here if we want, like we could define it in this game class. I'm not going to, just for the purpose that, say we actually want to draw or play maybe like 4 or 5 chess games at the same time. Well, we could in theory pass a window that is big enough that we could draw 4 chess games, and then we could just pass subsets of that window to different games and play multiple games at the same time. So I'm just trying to keep things flexible. We could define win here. I'm not going to, but just figured I'd tell you why. So first I'm going to say self.selected equals none. This actually reminds me that I want to go back to board and remove the selected piece, because we're not going to use that inside of board. We're going to use this inside of game to figure out what piece is selected by someone that's playing, if they are. And then next I'm going to say self.board equals board. So that means from main here, we're actually not going to make a board. We're actually just going to make a game, and the game will control the board for us. So rather than having to get the piece, move the piece, all of that, all we'll do is use the game to say, okay, we selected this row and column, move it to this row and column, and that will figure all of that out for us. So self.board equals board. Next, we're going to say self.turn equals red, which means we need to import constants. So from dot constants, import red, white. What else will we need? Probably a few other things, but we'll just leave red and white for now. So self.turn equals red. And after that, we need self.valid _ moves equals a dictionary. We'll talk about this after, but this is going to pretty much tell us what the current valid moves are for whatever player is playing, so that we can draw those or we can move those or whatever it may be. Next, we're going to say self.win equals win. So just store that window in here so we don't need to pass it every time. And then what we're going to do is define an update method. So update will just be like, say we're updating the Pygame display. Instead, we'll just simply call this update method. So we'll say inside of update, self.board.draw, and then anything else that we want to do to actually kind of update the game. And then next, we'll say pygame.display.update. So now, right, if we go back to main, all we have to do actually is, instead of saying board.draw and pygame.display.update, we'll say game.update like that. Instead of making a board, we'll say game equals game. So now in theory, we've just kind of wrapped some of this functionality in. So I'm going to get rid of those 2 lines. We're not going to use those for right now. And we need to import game. But once we import game, all we'll have to do is just use the update method, the move method. It's a lot simpler on this end when we do that. So let's say from checkers.game import game. And let's run this and see if this works. Okay, so I'm getting an issue, missing a positional argument win. So I forgot I have to pass the window to my game. So let's do that. And what is this now? Board is not defined. So we need to actually import board into game. So let's do that. And now let's try it. And what's the error this time? Missing one required positional argument win. Okay, so let's go back to game. Sorry guys, and let's say self.win inside of the call to self.board.draw. Okay, and there we go. Now it's working. So we can see that it all works the same. We've just kind of wrapped it up and are using it a little bit differently. All right, so now let's go back to game and let's start defining a few other methods that we want. So first I'm going to define a reset method. This is pretty straightforward. Just say we want to reset the game. Then what we'll need to do is say self.selected equals none, self.board equals board, self.turn equals red, and self.valid moves equals blank. And in fact, that looks really similar to what all of this stuff is, right? So let's wrap this in a new method. And let's just say define, and let's actually just call this init. So inside of the reset method, we can just call init like that. And I'm going to make this private, just putting an underscore beside it so that no one else can call this. They have to call the reset method. And then here, what we'll do is we'll just call underscore init. So the logic behind this is that since we're doing the same thing twice, but there's a little bit difference in the init method here, let's just put it in a method that does it. And rather than having the user just call init, right, what I will do is have them call reset. The reason for that is that init technically is initializing the game, but we don't want the user to have to call an init method when they want to reset the game, right? So just so it's more clear for them, we make this private so they don't see it. They only see the reset, and really all it's doing is just calling init, which is also used by the initialization of the game. So it's just about what we're exposing and showing to whoever's using this class. Yes, we ourselves are using this class, but you have to imagine that maybe someone else is using it, or maybe we're going to use it in a different capacity. So it makes more sense to have methods that are named the right thing. And then inside of init, we're going to have self like that. Okay, and this will be self.init and self.init, my bad. Okay, so now that we've done that, I'm going to add a method for select. So this will say select a row and column, so self row call. And we will have move. So define move self row call. All right, great. So this is pretty much saying, all right, when you select something, you will call this select method. You will tell us the row and column that you selected. And then based on that, whatever information we're currently storing in the state of this game will do something, right? So if you already selected a piece, then maybe we'll move it. Or if you selected a different piece, we'll change that selection, right? That's what we're going to do. So I'm going to say if self.selected, so if we have something selected, because note right now selected is equal to none, then what we'll do is we'll say result equals self.move of row call. Now, this won't make too much sense right now because we haven't defined this move method. But what I'm saying is, okay, if we already selected something, then let's try to move what we've selected to the row and column that you put in here. The point of this being that I'm actually going to make move private. We only ever select something from the game. So when we are like moving stuff around or when we're giving any input to the game, we just call this select method. We say, okay, I selected this, I selected this, I selected this, blah, blah, blah. And this will handle what happens based on that selection. So we don't need to call move and select. We just call select, and select will determine whether or not we should move something based on what you've already selected. That's what I'm doing at least. Might not make perfect sense, but anyways, I'm going to say if not result, then self.selected equals none, and self.select row call. So essentially what's going to happen from this move method is if we were able to successfully move something, so if the row column that we selected was valid because we already had something selected, so we selected, say, a diagonal square that we could move to, then we will actually move it. But otherwise, what we will do is select a different piece, or at least try to select a different piece. So we'll say, sorry, let me re-clarify this. So what this is doing essentially is saying, okay, if we have something selected already, that means we already pressed on some piece. So we're trying to move the piece that was selected to whatever row and column we just passed here. Now let's say that doesn't make sense. Like maybe we pressed a red square and then we pressed a white square. Well, that's going to mean that result is going to be false. It's going to tell us, hey, no, that wasn't valid. Like you couldn't move there. So what we do is we reset the selection and then we reselect a row and column. So this is going to call this method again, except now we're going to get into the else statement that I'll put here, or not the else statement, but we'll get into the rest of the code that I'm going to put here, which will essentially say, okay, let's select this piece. Let's do that. Let's whatever, right? That's what it's going to do. So we're going to say piece equals, and in this case, we'll say self.board.getPiece row column. So we've used this before, but we're going to use it in here. We'll say if piece does not equal 0. So if we're not selecting an empty piece, we're actually selecting something that's red or black and not black, sorry, red or white, and self.piece.color, and actually it's not self, it's just piece.color. If piece.color equals self.turn, so whatever turn it currently is, then what we can do is actually select that piece. So let's say self.selected equals that piece, and we'll say self.validMoves are equal to self.board.getValidMoves, which is a method we're going to define in a second, and we'll simply pass in that piece. And then we will return true to tell us, hey, this was right. We selected something, that's good. Otherwise, we'll return false. So this is just to tell the user, hey, this selection was valid, so we're returning true to you. If it's not valid, we're returning false. And that's the basis of how this works. So again, we'll go through it. If we selected something, then try to move it to whatever else we just pressed here. If that doesn't work, so we get a false back, then say, okay, get rid of our current selection, reselect something else, which means call this method again. And that means we'll do whatever happens here. Now we could put an else statement just to make sure, in this case, return false is fine, just to make sure that we're not going to accidentally run this code after the self.select happens and we return back here, if that's making sense, because this is technically recursive, but anyways, that's what I'm getting at. So we can go over this again later, but I think that's enough of an explanation. Okay, so now we're going to do move. So move is called here, and now we need to actually move something if this is called. So we're going to say piece equals self.board.getPiece row, comma, column. Next, if self.selected, so if we have actually selected something and the piece is equal to 0 and the row call is in valid moves, which is going to be self.valid_moves. So hopefully this is reading clean enough that it makes sense, but essentially if we selected something and the piece that we selected is 0. This is important because we can't move into a position that has another piece. So only if we selected something and what we selected is actually not another piece, because at this point we've, okay, so we've already selected something, and then what the row and column that we pass here that we're trying to move to is not another piece, if that's the case. So actually I don't think I can say, yeah, if piece is equal to 0 from row and column that we just pressed on, and the row and column that we want to move to, right, is in the valid moves, then we can actually move it. So we can say self.board.move, and we can move the piece, which we would have had as selected. So self.selected, we can move the selected piece to the row and to the column. Okay, so I double checked that. I'm pretty certain this is right. I've been confusing myself because there's a lot of rows and columns and the same words everywhere. But we'll move the currently selected piece to the row and column that was passed to us here. And this will work. We've already set up how the board moves the pieces. And then what I'm going to say is, this will be weird because we haven't seen this yet, but skipped is going to be equal to self.validMoves. You know what? Actually, let's skip this because I don't want to confuse anyone if they if we haven't yet wrote the code that we're about to try to like work with, if that makes any sense. But otherwise, if this is not true, we're going to return false and then return true if this actually works. Now, the other thing we need to do is actually change the turn. So I'm going to say define change turn self, and we're going to say if self.turn equals red, self.turn equals white, and otherwise self.turn equals red. So change turn, just to make this a bit cleaner to see, and then we'll call self.change turn. All right, so valid moves, we haven't looked at this yet, but this is going to be a dictionary of the valid moves that we can take from any possible position. And then we have change turn, which is going to say, okay, if it's red, we'll go to white. If it's white, we'll go to red. So pretty straightforward. I want to see now if I can get select to work, or if this is working. The only problem is we're not drawing anything, right? So I won't really be able to see if what piece I've selected is working or not. So we're actually going to have to keep writing code until we can really test this and make sure that we haven't messed anything up. Okay, so now it's actually time for, in my opinion, what the fun part is, which is trying to figure out an algorithm that can essentially be given any piece and determine all of the valid moves for that piece. Now, unfortunately, my like drawing software isn't working. I'm going to try to get it working. If it doesn't, then you'll be seeing me hand drawing something in just a second. All right, so now I got the drawing stuff to work, fortunately, so I don't have to actually go and get a piece of paper and film myself doing that. But what I'm going to show you is essentially how we figure out what pieces or what moves pieces can go to based on where they are. That's a mouthful and I still didn't say it correctly. But let's say we're considering this red piece right here that I'm filling in, so this red checker. Essentially, what are the valid moves for this piece? I'm going to draw them in green. So one of the valid moves would be this. Another one would be this, right? To hop over this piece. But if I move this piece, so I remove this blue one, then no longer is that a valid move. The valid move is, if I can go back to green, this one right here. So this is actually kind of tricky because it looks simple. It looks like just expand on the diagonals and figure out where you need to move to. Just say, okay, is there empty space on the diagonals? If there is, you can move there, right? But then again, what happens if I add a checker right here? So I add a blue one right here. I can no longer move here. I can only jump over top. And if I add another blue one right here at the end, now I can't even move on this diagonal at all. So hopefully you can understand kind of the complexity in this and why the algorithm we're about to write is actually kind of complicated to figure out where a chess piece is, or a checkers piece is able to move. Essentially, we need to look at all of the checker pieces on the diagonals of where that checker piece is. And now imagine the situation in which this is a king. So if we give him like a little crown or something, that's sure, this will be our king. It's not really a crown, but if it's a king, it can move backwards, right? And it has the same rules applying to it, except it can move backwards as well. And then what happens when we can double jump, right? So if we have a situation, I don't think I can even set one up where we can double jump. Let me see if I can. Okay, let's see if we can get a double jump set up somewhere just to show you an example. If I have a piece here and I have a piece here, and then imagine that this expanded on, technically a valid move is right here in this square for this piece. It can jump here and then it can jump over there and capture both of these pieces. And we need to keep track of what pieces we jumped over so that we know if we remove them. So it seems pretty simplistic, but actually moving these pieces is pretty complicated. So let's consider the algorithm that I'm actually going to run through. I have it up beside me. I'm going to bring it up beside me at least, and I'll show you what I'm going to do. So the first thing that we're going to do is check the color of the piece. So is it red, or in this case, is it blue? But this would be white, obviously. I'm just doing it in blue because you cannot see white on this background. Okay, so the color, is it red or is it blue? That determines the direction that we're going to move in. And in fact, I think we already have the direction set on the piece as either -1 or +1. So let's say that we're considering something that's red. We can only move down in that direction. So what we're going to do is look on this left diagonal and this right diagonal for any valid moves for this piece. We can only move diagonally again, right? So what are we going to do? The first thing we're going to do is we're going to move down one row. So whatever row this is on, we're going to start from this row right here. And we're going to, if we're checking the left diagonal and the right diagonal, we're going to check one at a time. So I'll start by checking the left diagonal here. I'm going to look to the square that is one left and one down, so on the diagonal right here, and say, okay, does this have a piece in it or does it not have a piece in it? So the two things here are, okay, if it has a piece in it, is the piece blue or is the piece red? So is the piece the same color as our piece? If it is, we can't move on that diagonal. So if this piece right here is actually red, then we can't move here, right? Because we cannot have a red move into a piece where another red is. Now, if the piece is empty, so if there's nothing there, we can move there. That's a valid square. So if it's empty, then we say check, okay, boom, we can go there, that's fine. If it has the opposite color piece in it, then we have to keep moving on the diagonal and see if we can jump over this piece. So if there is a piece on this diagonal, we need to check the next piece here and see if we can move into that square. So if there is not another piece in this next square over, doesn't matter what color it is, then this becomes a valid move and we can move into this square. Now this applies the exact same way on the right side of the diagonal as well. We'll move over one and to the right, and we'll say, okay, is there anything here? In this case, there's not, so we can move there. But if there was, we need to check the color of it. If it's the opposite color, we need to check continuing on the diagonal and see if we can move over top of that color to jump it, right? And if we do jump that, we need to keep track that this move would jump a piece so that we can remove that piece if we decide to take that move. Now, where it gets a little bit more complicated is if you're double jumping or doing something else. So actually, let me just erase all of this and draw a fresh grid because it's getting kind of messy here. And I'll talk about how we handle the situation in which we're double jumping. So let's just say this is our grid. It doesn't have to be even or neat. It's just for the purpose of showing you here. And let's say we have, maybe we can change the colors again. We have our red checker here. Then we have a blue one and a blue one. And we'll expand this out like that. Okay, so technically, we should be able to move here to this square to double jump. So what I'm doing, at least in my algorithm to check this, is saying, okay, if we jump over a piece and we land in a square that doesn't have another piece in it, from this square, check if we can jump any other piece on the diagonals. So we already know how to check if we can jump a piece, but imagine that there's a piece here and here. Technically, this is a valid move, because if we move here, we can actually jump over to the other side and jump the other piece. So that's something to be aware of as well. So as soon as we go here, I'm actually going to run the exact same algorithm I ran before, right? Except this time, I'm only going to consider a move valid if it jumps over another piece for the double jump or triple jump or so on and so forth. So as soon as we jump a piece, we immediately consider if from the current position that we jump to, we can jump any other piece. And if we can, we add those moves to the valid move set. So that is how we're going to do this. I'll write the code for it, which is more complicated than this. And then that will be probably the hardest part of this video, is writing this little bit of algorithm here. All right, so let's get into it now. Bring the keyboard back, get rid of all the wires for my drawing tablet, and there we go. Okay, so what I'm gonna do is I'm gonna say, define inside of board.py get underscore valid underscore moves, and this is gonna take self, and do we wanna take a piece, or do we want to take, or we'll take a piece instead of row and call. All right, so first I'm going to say moves equals an empty dictionary. What I'm going to do in this dictionary is store the move as the key, so what place we could potentially move to, as a row call. So like 4 or 5 might be a available space that we can move to. And I'm going to have this as the key being equal to any pieces that we jump to that move. So say that we jump over the piece in 3-4 to get to 4-5. Then that would be stored in a list that is associated with this key in the dictionary. So, more accurately, be it like that, so that we know if we move to this move, we have to remove that piece because we jumped it. All right, so moves equals empty dictionary. I'm going to say left equals piece dot call -1, oops, because we're moving left 1, and then right equals piece.call plus 1. So essentially just getting the, what's left and what's right, because that's the diagonals we're going to start considering. And then row equals piece.row, like that. All right, so now what I'm going to say is actually, I need to check something here. Yeah, the direction that we have on this piece is actually, if I can find it, do I have direction? Not going to be relevant, so we can actually just get rid of it because we're not going to use that. We have to do it another way that I forgot. So inside of here, what I'm going to say is if piece.color equals red or piece.king, we'll do something. If piece.color equals white or piece.king, do something. The reason I'm doing this is because we need to check whether we can move up or whether we can move down based on the color and based on if this piece is a king. That's what we need to do. Now, what I'm going to do is I'm going to define two more methods. I'm going to say define underscore traverse underscore left, which is going to look on the left diagonal for us because we're going to have to do this multiple times. I'm going to say self pass, and I'll fill in the rest of the parameters after. And then next, we're going to say define underscore traverse underscore right, which is going to move to the right. So we have two methods here that we're going to call from inside of here to kind of split up this algorithm and just make it a little bit more digestible and easier to see. But for our traverse left, I'm going to say, where do we start? Where do we stop? How much should we step by? And what is the color left? And I think one more thing, skip only equals that, or skipped equals that. Now I'm going to copy these and I'm going to put them inside of traverse right. Now let me just explain why I've added all these. So start, stop, step is going to be for the for loops we're going to put inside of here. The step is the most important because essentially it's telling us, okay, do I go up or do I go down when I'm traversing through the rows for the diagonals? Am I going on the top left diagonal or the top or the bottom left diagonal, right? Am I going on the top right diagonal or the bottom right diagonal? Skipped will tell us, okay, because we're going to call this method recursively, which you'll see in a second. Have we skipped any pieces yet? If we have, we can only move to squares when we skip another piece, right? That's what this is telling us. And left, sorry, this should say right in traverse right is telling us, okay, where are we starting in terms of the column when we're traversing to the left? Okay, so that's what this is telling us. So inside, we're going to fill in traverse left and traverse right, and then we'll use them inside of get valid moves. So if traverse left, I have to look at my other screen here because there's no way I'm going to be able to do this just off the fly. I have to say moves equals a empty dictionary. Last equals an empty list. We're going to say for R in range. R is going to stand for row, start, stop, step. So again, the point of this is that I'm giving the parameters for my for loop in the, I'm giving the arguments for my for loop in the parameters so that I can simply just put them here. And this will tell me, okay, what row am I starting at? What row am I stopping at? And what am I stepping by? Awesome. Okay, so start, stop, step. Next, we're going to say if left is less than 0, break. So if we get to a situation where we're now looking outside of the board, so our left is no longer in the range of columns that we have, because we're going to subtract from left every time in this loop. In fact, we can just do that like this at the end. Then we need to break. All right, so we're looping through all of the rows and we're going to have a variable that keeps track of left for us that we just increment as we move through the rows. This again will move us kind of on a diagonal pattern, which is what we're trying to look for. We're going to say current equals self.board.get underscore piece. And we're going to put R left like that. So row and then left, which is the variable keeping track of, again, the column that we're on. I'm going to say if current equals 0. And now we need a more advanced thing inside of here. And by the way, we're going to copy almost all of this for traverse right. So once we do this, there's just a few minor changes. So if current equals 0, meaning the current thing we're looking at, if it is 0, then we need to check if skip underscore only and not last, then what we'll say is break. Okay, so to explain this is kind of complicated, but what we're gonna do, and maybe it actually would be easier if we call traverse left first, just so that I can kind of illustrate this better. In fact, that's what I'm gonna do. I'm simply gonna say here, moves.update self._traverse left. And then what I'm gonna pass is row -1. I'm gonna pass the max of row -3 and -1, and I'll talk about this in a second. -1 piece.call. Wait, is this correct? Sorry, piece.color. We need the color and left. Okay, so what I'm saying is I want to update the moves with whatever is returned from here, which is going to be another dictionary. I'm traversing left. I'm passing row -1, which means, okay, if we're red, we are moving up, right? So we need to move, we need to check upwards to see if there's anything valid there. So we're going to start, remember this is the first parameter here, start at the row above the current row that we're at. We're going to say, okay, how far up are we going to look? How many rows up am I looking? Well, I'm going to look at row -3 or -1, so the maximum of that. Now, -1 pretty much says stop at -1, which means look up to row 0, right, which is a valid row. And the reason I put row -3 is because I don't want to look further than 2 pieces away from where I currently am. And if I start at row -1 and I move to maximum of row -3, right? Then what that means is I'm only looking 2 above the current row that I'm at most. So that's why I'm putting row -3. -1 is saying move up when we increment this for loop or decrement this for loop in this case. The color obviously is the piece color, and left is where we're going to start for our column and what we're going to subtract as we move upwards. That's what this moves.update is doing. Now I'm going to do the same thing for moves.update with right, except it's going to be changed a little bit. So move.update traverse right. The start-stop step is going to be the same. Piece.color will be the same, except instead of left, we're obviously going to pass right. Now let's do the same for white, just to show you what I mean. Hopefully this will make it more clear in this order of explaining. And instead of, traverse left is right, except now instead of row -1, it's going to be row +1, because we're moving down this time, right? And now instead of the max, it's going to be the min of row +3 or rows. Right? Hopefully this is making sense. And then instead of -1, it's going to be 1. And left and right is the same. So I think that's right. Let me make sure I did that correctly. Yes, it is. And then outside of here, we'll return moves. So this method right here, traverse left and traverse right, will return us a dictionary. Essentially what moves.update is doing is merging this dictionary with the one we currently have, so that we can have as many things as we want in that dictionary. We don't have to say moves equals this and then go through and add them automatically. This method does it. Okay, so hopefully that's making sense on how we're going up and how we're going down. But what I'm saying is if current is equal to 0 and we skipped a piece and we have not seen a piece yet, so we'll define last in a second, but if we've skipped a piece and last, which is a piece that we would skip to move to where we're going to go, is not defined, then break. The reason for that is if the next square we look at when we jump over a piece is a blank square, we can't move there because we need to jump to another piece, jump over another piece to be able to actually make that a valid move. Now, this will make more sense as I complete the algorithm. I like to explain things as I go, but sometimes you just have to walk through all of it and then kind of go through parts after. So elif skip only, we'll do something in a second, and else we're going to say moves. And this will be our left is equal to last. All right, and then finally, what I'm going to do, not finally, there's actually more to this. I'm going to say if and last, why is that an error? We'll see in a second. Say if last, then what we're going to say is if step equals -1, row equals the max of r minus 3, 0, else row equals the min of r plus 3 rows. So this is now doing the same thing that we did before, because what I'm preparing to do essentially is saying, okay, if we found an empty square and last had a value in it, so there was we found something when we were looping, which, you know what, I'm just going to keep going and then I'll explain this. So if current does not equal 0, what I'm going to say is elif current.color equals color, break, else last equals current. We're going to put this inside of a list. Okay, now I'm actually almost done with this, but I just need to code out a good amount to be able to start explaining this. So if current is equal to 0, that means we found an empty square. Otherwise, if it's not, so if it has a color, it wasn't equal to 0, and it's equal to our current color, so the piece we're trying to move is equal to our piece, then we can't move there. Obviously, we're blocked. We can't jump over it, so we break, and we won't be adding any moves if that's the case. Otherwise, we say, okay, if it wasn't our color, it means it was the other color, which means we could potentially move over top of it, assuming that it's an empty square next. So we say last equals current. So then what happens in this instance, we're seeing if we can jump, right, which is the complex aspect. Last gets equal to current. We loop again and we look at the next row and we move left and we look at the other diagonal piece. We say, okay, if current now, so if this next piece is 0, and if we skipped and not last break, I'll talk about that after. If skip only, we'll do that. But in the situation where it's 0 and none of this was true, we add this as a possible move. So we say, okay, if it's 0 and last existed, right, then that means we can jump over it. So we say moves r comma left equals last. Now, in the situation where we find this first and we don't just find a piece that is the other color in between, we will add the move, but we just won't skip anything because last will be equal to an empty list. All right, now we're saying if last, so essentially if current was equal to 0 and last, which means that we had something that we skipped over, now we can actually skip it. We're preparing to see if we can double jump or triple jump, right? So that's what we're trying to do. So what we do now is we say, okay, what direction were we going? Were we going up or were we going down? Because we need to recalculate, and this shouldn't say r plus r, this should say r plus 3. We need to recalculate where we're going to stop because now we're at a new position when we recall these two functions. So what we're going to say now is moves.update, and we're going to say self._traverse left, which is the same one that we're doing here. We're going to say r plus step. So either we're going up or down based on what the step is. If step is -1, r will subtract 1. If it's 1, we'll add 1. Say r plus step. We'll say row. And actually, is it row? Sorry, this should be r plus step. Yeah, row. And then in this case, step, because we already passed the step, so we know what direction we're going in. Then what do we need to pass after that? We need the color. Okay, we're going to pass left -1. And finally, we're going to pass skipped equals last. Okay, so that's what we pass for that. And then we'll copy the exact same thing, move down a line, and do this now except traverse right. And instead of left -1, it's going to be left +1. All right, so let me make sure I did this correctly. I think I did. But the whole point of this is like once we get to a point where we've skipped over something. So in this case, we found a valid square. We skipped over something. We figured out, okay, now where are we going to go to figure out if we can double jump or triple jump? What row do we stop at? We call this again recursively, which means just do it again and see if we can double jump or triple jump from this position. And then we actually can just break here. It won't matter if we put a break or not because based on the way that this for loop is set up, it won't run anymore. But I'm just going to break just so we're clear that after we do this, there's no more valid moves in this current iteration. And now I need to fill in this pass here for skip only, but it should actually just say skipped. Okay, so let's go to skip now. If skipped, we're going to say moves r comma left. And yeah, r comma left equals last plus skipped. So essentially, if we're in the situation where we found a valid move, we skipped over something, right? Now what we can do is we can actually, sorry, this is the situation where we're double jumping something. We will combine the last checker that we jumped with the checker we jumped on this move into this move's skip so that we know whether we can jump 1 or whether we can jump 2 and which ones we need to remove. This is all going to make more sense as we continue doing it, but just it's hard to explain this because it is a really kind of abstract, complicated algorithm without really a visualization. Now, the reason we have this break here again is essentially we're saying if we've skipped over something, we found a blank square, and we don't have anything that we can skip again, we can't move there. That's what this is saying. So that means all we have to do here is check if we've skipped, because if we skipped and we did find another thing that we can skip over, then we can update the mover, add another move that has the last plus this one. If none of this is true, if we didn't skip anything, so we're on the first one, as soon as we find an empty square, this is valid, moves are left equals last, right? And there we go. And then we check and do this recursive call to see if we can skip any more from that blank space. That is kind of how this works. Again, hard to explain, but that's what we have to do to get this to work. And now I'm gonna go traverse right. I'm gonna copy all of this, and we're just gonna update a few of the variables. So instead of left, we're gonna say right, and instead of right being less than 0, it's gonna be right greater than or equal to rows. And actually not rows, is gonna say calls. Now, current, that's fine. Instead of left, again, this says right. So pretty much anywhere it says left, just substitute it with right. And some of the minuses and pluses we'll have to substitute as well. Yep, and this will say right. Instead of right minus equals 1, this is gonna be right plus equals 1. Instead of left, this is gonna be right. That can stay the same with plus 1 and minus 1. And let's see if there's anywhere else. I think that should be good. And finally, let's return moves from this and from this. Okay, so this is the algorithm to determine the valid moves based on a piece, right? So given a piece, tell us all the valid moves. This will do it. I don't think I messed it up at all. And now what I want to do is just add something that can draw these valid moves so we can actually make sure that this is working. So next, what I'm going to say is define draw underscore valid underscore moves. And why is this break giving me an error? Let's see what it says. Instance of list has no get piece method. Current equals self.board. Oh, oops, sorry. So this should say self.board. My apologies, guys. We're going to have to make a quick fix here. Line 78, self.board are left, because we're inside board, not game. I forgot, so the internal representation is different. And then here, same thing, self.board are right. Okay, so that should be good. Now let's go to draw valid moves. Let's say self. We can say, should I say moves? I'm just gonna look at where I've done this before. So actually what I'm gonna do is I'm gonna take this method, and I'm gonna put this inside of game, just because game handles most of the drawing. So inside of here, we'll say define draw valid moves, self moves. And then what we will do is we'll say, okay, we need to just draw squares for all of these valid moves. So we'll figure out their row and their column, and then just draw a circle there for each move. So we'll say for move in moves. And then we will get the row and column. So we'll say row call equals move. Remember, all the moves are going to be a dictionary. Okay, so we say row call equals move. This loops through all the keys of the dictionary, which coincidentally is the rows and columns that are a tuple for us there. So row call equals move. And then pygame.draw.circle. We'll draw it on the surface, which is self.win. And then what we will do is we'll draw it. What color do we want? We want blue, which I'm going to import from here. So blue like that. We'll say self.x. Oops, not self.x. We have to actually calculate self.x. So I'm going to say row multiplied by square size. Row multiplied by square size minus square size over 2. That should give us the middle. And then same thing with call. So call times square size minus square size over 2. We've already talked about how that works, so I'm not going to go over it again. And then we need the radius, which in this case, let's just hard code at 15. Okay, so square size, we also need to import. So let's import that like that. And I think that's all I need to do for draw valid moves. Now inside of draw, or inside of update, sorry, where is that? I've got to find where the update method is. We'll say, oops, self dot draw valid moves, and we'll pass the self dot valid underscore moves, or self dot board dot valid moves. Okay, so I think that is, or no, we have it stored inside of here. What am I saying? Sorry, guys. After an hour and almost 2 hours of recording, the brain starts to go when I'm talking and doing all of this. But anyways, self.valid moves, which is stored in here, which should be updated when we select a piece. And now I apologize, it's been like 40 minutes since we've tested this, but I'm gonna run this and see what is happening. Oops, what is this going on here? Let's go back here. Okay, so now when I select something, nothing is showing up, which is great. And let's just check this. Okay, so I realized why nothing is showing up, because I just looked at this here. We have not called the select method of our game at all. So we need to actually call the select method. So what we're gonna do to do that is we're simply gonna say game.select row call whenever we press on something. And that should be good. Let's check that out. And actually what I'll do here is say if game.turn equals red. So pretty much just let us select the red ones is what I'm saying here, because later we'll make we need to import red. Later we'll make the white ones the AI, but let's run this and see now if we get anything. Okay, so I've select, and okay, so it's giving us some moves, but clearly these are not valid. So I'm just gonna have a quick look at the bug that I made, and then I will be back and we can discuss what is going wrong. So I've made a stupid mistake here by mixing up inside of the draw move, the draw valid moves, the row and the column. So I was like looking through all my code, like what the heck did I do wrong? Like where did I break something? When in reality, this just needs to be changed from call and row, because I'm drawing the row I'm drawing like the X and Y reversed. So I was like, this looks like it's like getting it right, just drawing it opposite. And that's exactly what it was doing. So I did some debugging and figured that out. I'm trying to figure out where else. I think I printed some stuff out that I want to remove. Maybe not. Anyways. Okay, but that was the major issue. Also, there was a small mistake. I had a break statement. I think I went over this, but on line 92, the break statement was indented. Just needs to indent, is that what you want to call it, out here, so it's in line with the if statement. Same thing here in traverse right. So let's look at this now. All right, so one more error here in this draw method. I just looked at it, I'm like, what the heck, what have I done wrong? These negative signs need to be positive signs. So what I was doing is saying, okay, we're gonna go to the edge of the square, so the top left edge, and then subtract from the top left edge, which meant we were going up into the other square, which is why it was going off. So that was the issue, but now change those negative signs to positive signs inside of here between the square size and square size over 2, and hopefully, fingers crossed, let's click something. Everything looks to be working. Okay, great, so that's awesome. So that is pretty much how this works to get the valid move. So I apologize to everyone for butchering that horribly. And I'm trying to make sure that the white and red, I think the checkerboard pattern is good. Now we need to worry about actually jumping over pieces, updating the valid moves. You can see that worked to actually move where I moved it, but there's a few glitches, so let's fix that now. All right, so let's go back into game. Let's go into the select method that I don't think I actually ended up finishing. And let's just check and make sure this is all good. So first of all, I need to get rid of this else statement, which I realize is a mistake, and put it like that. I'm not going to explain exactly why, but just don't add that else statement. That messes it all up. You can read through this and go back. I think I explained kind of how this works. Okay, so after that, what we'll do is go back into move, and now we'll make it so that if we skip over a piece, we actually capture that piece. So we're going to move the position is what we've done. We'll change turns, but what I want to do is check if the position we moved to had a piece skipped. So I'm going to say skipped equals self.valid moves, and not piece. We're going to say valid moves, and inside of here, I'm going to say row column. Now we say if skipped, and then what we need to do is say self.board.remove skipped, like that. And then actually we can just put change turn at the end, because I think it makes more sense to go afterwards rather than before. And looking at that, I think that's all we need inside of here. Just double checking, looks good. Now we need to add this remove method inside of the board class here. So what I'm gonna do is say define remove self pieces. And what we'll do is loop through all the pieces and just remove the ones we need to. So we'll say for piece in pieces, and then simply say self.board, and we'll say piece.row piece.call equals 0. So that should be as easy as it is to remove all of these, loop through all the keys that are in this, because it's going to be a dictionary, or not dictionary, it'll just be actually a bunch of pieces, and we will simply just remove those pieces. So we'll just set them equal to 0, which, at the same time, we'll remove them. Okay, so now that should work. Let's see how this works now if we run. Okay, so let me go here. Now let's see if I can move white. Oh, I can, great. And what's something that's happening here? So I noticed that when I'm moving, it doesn't, at the end of the move, remove these valid moves. So we have to do that. So let's actually do that now. Let's go to move. And yes, at the end of valid move here, where it says self.change turn, let's go inside of change turn and let's say self.valid moves equals a blank list. Okay, so that should hopefully fix that. Let me close this and restart it. And now let's test some stuff out. So first of all, I can't move to any places that aren't valid moves, right? So click on a piece and try to move it somewhere else. You can't. You can only move it to a place that is valid. So I can move it there. Now I can't move these pieces or even select them because it's not my turn, but I can select the white. So if I select this one here, now let's go with the red and let's see if we can jump over, and it looks like it's working. When we jump, it actually captures it. So really, with that, this is the finished checkers game. What we have to add as well now would be checking if someone has won. So I'll show you how we do that quickly. And actually, let's just make sure that the king pieces work properly before I say that we finish the tutorial. All right, so we capture there, capture there. I'd like to set up some kind of double jump and make sure that that's gonna work at some point too. So let's do that as well, actually. Not doing a great job at setting it up though. Okay, let's move this here. Whose turn is it now? My turn. Okay, let's go here. We can go there. I'm trying to move this. I guess I can't move it down. I wanted to move this one so we could double jump, but anyways, let's see if we can just get a king piece first as well. Okay, so let's move that there. This can go here. That can go there. All right, move you here, here, go there, and king. Okay, that looks like it's working. And now it's white, and when I press the king, I can jump backwards over the other pieces. Okay, so that's great to see. That looks like that is somewhat working. Now, let's move this guy here. And it's hard to play the same game against yourself. I'm just trying to get a double jump set up. So let's move that here, and let's see. Okay, so it looks like I can double jump and that this is indeed valid. Now, it'd be cool if I could have done a triple jump. In fact, maybe let's see if we can get a triple jump and just really test ourselves out here and see if that's working. So to get a triple jump, I'm gonna make this guy a king. And it looks like something went wrong. So good job, we were testing that. List index out of range, board R right. So actually, when I moved to the last square, we had an issue. So let me just look at the code and see what's going on there. So first, the mistake is here. I had row equals rows. Obviously, that's never going to be true because we can't move into rows, which is 8. We can only move into potentially row 7, but based on the way it's indexing. So I'm saying if row now equals row -1, then in that case, we can make this a king. So that should fix the fact that that guy didn't go to a king. But now I'm trying to figure out what the issue was with that index out of range. And let's have a look at that. Aha, so I've found the culprit here again. This max on line 69 should say min. So what happened was we were maxing row +3 or rows, which meant we were going to use whatever the larger one was. So we'd use row +3 when we were traversing, which meant we would try to go down from when we moved into that position. And obviously that wouldn't work because there was no more rows to look at. So let's just kind of run through and test one more time. I'll add one thing to check if someone's a winner, and then we'll pretty much be done. Okay, so let's do that. Let's do that. Let's see, you go there. You can jump. I just want to move a white to the other end to make sure that all of that is working. Okay, let's just keep going. And white. Okay, so now he's king, and now it's the red's turn, and there we go, he can move here. Okay, so that seems to generally be working. I'm gonna test just one more time and see if this double jump works. So this is crazy. Look, he can go boom, boom, and if I go there, it actually captures both of those pieces. So this is working properly. Great, so I am satisfied that this is functioning, that the game is working, we can move around. Of course, you can add some music, sound effects, make it look better. I'm not focused on that, I always focus on the function first. And now let's add one thing to check if someone has won, and let's go actually back to board. Let's go to remove, and let's update that method because I remember that I forgot to do something. So now when we remove a piece, I want to actually check if that piece does not equal 0, first of all. And so if piece does not equal 0, if piece.color equals red, then remember we have this count up here for the red and white left that we need to update. So now what we'll say is, okay, if piece.color equals red, then self dot, I believe it's red left minus equals 1, else self dot white left minus equals 1. Now we can even add a winner onto here. So we can say define winner, and this will return to us the color that won if they won. So we'll say if self dot red left is less than or equal to 0, return red. Elif self dot white left is less than or equal to 0, return, oops, sorry, this should be the other way around, return white and return red. And then finally, return none in the situation where no one won. So return none like that. Now, I'm not going to actually like program anything related to that, but what I'll do is simply just say if game.winner does not equal none, then print game.winner. Could simplify that, but this is fine for now. And this is pretty much, I'm just trying to show you, if you want to check if they win, just do this. And then inside of here, you can do something specific. In my case, I'm literally just going to print out the color of the winner because I can't be bothered to add any more to this now. So with that being said, this has been Checkers. All right, so I am back and it is the next day, and I just read through this code and tested it, and I realized that I made a kind of small mistake at the end, so I just wanted to hop in here quickly and fix it for you guys in case any of you were running into problems. So essentially, some of you probably noticed this, but when I said if game.winner, I didn't actually add this winner method to the game class, I added it to the board class. So that's fine, we can just add another one to the game class that simply uses the one from the board class. Really easy fix, but I just wanted to hop in here and show you how to do that. So we're just gonna have to define winner inside of our game class. We'll take self here, and we'll simply just return self.board.winner. So that's it. Let me just run this and make sure that everything's working now. And we can see that it is, and we're good to go. So let's get back to the original video. If you guys made it to the end of this video, give yourself a pat on the back because I hardly did. It is much more difficult than you would imagine to go through and explain about 400, 500 lines of code, especially because I'm doing this pretty much in one take, only cutting out like any major mistakes I make. So if you guys appreciate this, please do leave a like, subscribe to the channel. All the code will be available in the description in case your game isn't working or something is messed up. And yeah, let me know what you thought of this series, and hopefully you're looking forward to adding to the AI to this, which we'll be doing shortly.